Okay, welcome back to a new video of RoboCNC. I'm Marcel. The new video series, the RoboCNC X2 Router, first video. If you have seen my vlog 101, well, I think it was my first vlog video. If you've seen that one, you've seen a quick overview of the CNC machine. And today the first video of the new series, and let's start to build it. We're going to start with the Z-axis, so the axis that is going to be going up and down. Well, let's dive into the Z-axis. Let's first take you into the drawing side, the cut side of the story, and then go to the workshop and start building the Z-axis. I think the Z-axis video is gonna be split up in 2 or 3 parts, but well, we're starting today. Let's dive in. So welcome into the CAD side of the story. Well, this is gonna be the improved Z-axis, or well, the improved Z-axis if you compare it to my old Z-axis of the RoboCNC X1 router. One of the first things to notice is the heave-in carriages and the heave-in track. So not using the Chinese guide rails anymore. I'm going to use the heave-in track. So the 20 millimeter is going to be the Z-axis, or sorry, the Y-axis going on the bridge from left to right, and 15 millimeters on the Z-axis travel. So this travel. Well, one of the things to notice is that the rail is mounted on the moving part this time. So the rail is stiffening up the front plate of the Z-axis. I hope to get a lot of extra rigidity this way, instead of mounting the rail on the stationary part and placing the carriages on the moving part. That was a design mistake in the first router. Another thing to notice is that the carriages are mounted in the bottom of the Z-axis. So if the Z-axis goes down, it's sticking out not as much. So again, more stiffness, more rigidity in the Z-axis in comparison to my old Z-axis. You will also notice it's quite small or compact. All is compact on each other. If I look at the bottom, you see the ball nut, well, just clears everything around it. I have a small shop, so I need all my space. I need to build a small machine. I want to get maximum result out of it, so everything needs to be compact, especially the Z-axis. So these are some spacers to get enough distance between the stationary part and the moving part of the Z-axis to mount the ball screw. Ball screw is going to be the Chinese version, the RM1605. So it's a 60 millimeter diameter and a 5 millimeter travel per revolution. It will have one stationary bearing on top with a flex coupler and will be floating at the bottom. No need for a bearing on this side. Don't expect any problems with that. On top will be a 4 Newton meter stepper motor. Sensor over here. What's more to tell? Well, the front, you see these slots for the Woodruff keys. I'm planning on making this quite versatile. So I want to mount the motor on it, want to be able to take it off and put something else on it, like for instance a tangential knife or an oscillating knife or whatever. So I want to take the spindle off and put something on it, put something else on it, and make sure it's adjusted square to the table. Another thing to notice are these slots here. We have a slot of about 2 centimeters in length. I'm gonna try to do something new. You see the ball nut over here, and you see 2 brackets, ball nut brackets. The top ball nut bracket will be mounted in these holes, so they're, well, stationary. These 2 will not be connected to each other, or, well, not if it all works out. If it doesn't work out, I can mount these together and accept I failed. This one will be mounted to the ball nut. So the ball nut and this bracket will be screwed together. This bracket could slide in these slots. If I tighten or loosen the bolt, it could slide in these slots. So basically, if the ball nut goes up, the travel goes up, the moving plate will go up. If I loosen these bolts and I go down with the z-axis, nothing will happen, it will all go down. But if I put a depth stop over at the bottom and it touches the bottom, it touches the material, it could float. So the ball nut can go about 2 centimeters down and the top bracket will float. This way I'm trying to make a floating z-axis. So putting a depth stop in the bottom, having a material to engrave that's not completely flat. The idea of this is that it will slide on top of the material and move the curves that are in the material. So I have an engraving that's at the perfect depth everywhere. Not sure if it's gonna work, but well, we'll find out, and if it does not work, we put it up and we mount this together, and well, we will tell nobody. So this is about all to tell about the z-axis. I think it's time to go to the workshop and start building it. So welcome in the workshop. If you have looked at the design closely of the z-axis, you might have noticed that the assembly can only be done in one way. So I need to place the carriages on the back plate, so the stationary plate, before I can go any further with building up the z-axis. So I'll have to start to make a small part of the y-axis, or the bridge of the CNC machine. So the bridge is going to be made up of the item profile. This profile, a real heavy profile, 80 millimeters by 160 millimeters, and it's the natural type item profile. I got this straight off item. These are the Hewin rails, 20 millimeter Hewin rails, HG20R. I got these from Damen CNC. All links to the project and products will be provided in the description later on, with prices. So 2 of these rails will be placed on top of the item profile, and I'm gonna lock these with the profile nuts. These are the M5 profile nuts. They slide in, or they can be placed in the grooves of the item profile. Let's have a look at the part number. And I will mount these with the M5 bolts. Or the cap screws. So the Hewin blocks are the W20C blocks. I've already cleaned them and unpacked them. These are some heavy blocks. You notice one side is black and the other side is silver. The silver side is a machined precision ground side, so make notice that that will be the reference side. We're going to use that to do our measurements with. So this is the stationary backplate of the Z-axis. Notice the groove I made. This is to ensure a straight alignment with the Hewin blocks. So the reference side of all the parts will be mounted together to get a straight cut. So, and this is also needed to align the guide rails to the item profile. So let's start assembling all these parts. So the first step is to take the T-slot nuts and mount them on the Hewin rails. I found it's most easy to put the nuts and the bolts in the parts you're gonna place on the item profile and slide it in. It's a T-slot, so you can slide all the nuts and the bolts in there, which is quite easy. Well, let's speed this up. So now all the T-slot nuts are on the track. Take note that there's text with an arrow pointing to one side of the profile. Again, as I told you, we're gonna need some reference sides. So the arrow points at the reference side of this profile. I'm gonna assume this item rail or item profile is straight, or well, it's and it is. It's really straight. So I'm gonna mount the top rail. Well, it's in the bottom of your screen, but we're gonna call this the top item rail, Hewin rail, and we're going to slide it in. So the arrows are now pointing at me, which means the top will be our reference. This is our the point of which we're going to straighten everything out. As you can see, the rail can still slide into the T-track. So we'll have to use the dial indicator to align it to the top of the item profile. So after loosely tightening the Hewin rail onto the item profile, it's time to put on one of the carriages. Again, it's the 20mm, the W20C block, and I've already cleaned them and unpacked them. So be aware that there are ball bearings inside this carriage, and if you take out this plastic piece, the balls will fall onto the floor and your carriage is useless afterwards. I do not think we are able to put in the balls again. So make sure this does not slide out. Again, you see the shiny side is the reference side, and as we said, we're going to use a top reference of the item profile, and we're going to use the top of the rail and the top of this Z plate. All is going to be straight with the profile. Now still we have to make sure that the rail and the carriage are aligning with the item profile. So we have to put it on like this. Put light pressure on the plastic piece and slide it on the rail. And there it is. So this is the way to put the block on the rail. As said, we want to align the carriage with the item profile, and that way we want to align the rail with the item profile and the Z-axis. We're going to use this dial indicator with the magnetic base and place it on top of the carriage, or the linear rail block. So by setting the dial indicator to a known point, to 0 for example, I can now check all the bolts. So I adjusted the first bolt to be at the 0 point. It doesn't really matter if what the real distance, the absolute distance is to the top, but we're going to call it 0. Now we're going to go to the next bolt and adjust the rail slightly till it reaches 0 on the dial indicator, and then tighten the bolt. In this video I've used a small plastic hammer to tap it into place. Later on I found that it's even better just to put some slight pressure, bending pressure with your hand on the rail. It's all just the tiny amounts of movement you need to accomplish, and that works fine. So sometimes I do a small sanity check and see if everything's still 0. Go to the next bolt, bend the rail or tap it slightly until the dial indicator reaches 0, and then tighten the bolt. Well, using the method I just described, you can see this works really great. I'm over 1 meter of length, and I'm well within 2/100ths of a millimeter. So it's 1/100ths of a millimeter or slightly above. But well, I think that's really great over 1 meter length. So I put on an extra Hewing carriage, I put on the other rails and made sure also this arrow is pointing to exactly the same side of the item profile. And I rotated the whole bunch around, so the item profile is rotated. So the top of your screen is now also the top of the y-axis or the z-axis. The bottom item profile is just hand tightened, so it's quite loose, and I'm placing the other two carriages. Now it's time to find out how to align the bottom Hewing rail. I'm going to take the stationary back plate of the z-axis and make sure this edge is really clean. I'm placing it on top of the carriages and aligning the two reference sides, together. I'm going to use some M6 bolts, M6 by 20, to mount it on the top rail. So by using some pressure against the back plate of the Z-axis, I can now align the reference of the Z-axis with the reference on the bearing blocks or the Ewing carriages. Now tightening the bolts and keeping the slide pressure on. Now this way I know that the Z-axis will be exactly square with the Ewing rails and therefore with the item profile. So now with the bottom Ewing rail is still loosely on the item profile, we're going to mount the two bottom Ewing carriages to the Z-axis. And basically this way we use the Z-axis backplate to align the carriages and the Ewing rails together. So no dial indicator is needed for this procedure, just tighten the bolts and afterwards we're going to fasten the bottom Ewing rail to the item profile. While doing so, I'm about to tell you this is the last piece of this video. In the next video we'll build the Z-axis even further. All drawings will be provided and the links and price lists will be provided later on. Not sure if they're already in the description box, but well, have a look. Hope you liked the video. So well, this is it for this video, guys. Thanks for watching.